Hi everyone, I'm Nina, and this is my project Trees Across the US analysis. And it is basically a data science analysis of trees in major cities around the United States on a national level. And we are analyzing how biodiversity and density changes city to city. So, what is this data set? I had a lot of different sourcing, but I decided to work from Kaggle, and this is the 5 million trees data set, which is an accumulation of urban forest tree and tree population data across the US. I knew I wanted to work on a project that focused around the environment and something that is nature based in such a technological project. And I chose to do this with another data set that I worked on with an internship over the summer, which was an internship with the city of Minneapolis in urban forestry and environmental planning. And a lot of my work in that was specifically going out into the field, into the city of Minneapolis, and categorizing tree data using a system called GIS, or Geographical Information Systems. And by using this site, we had, with a system called Cartograph, we had this site that we would put all of our data together, and we could actually visualize tree populations and how to better the urban environment of a major metropolitan such as Minneapolis. So I knew I wanted to use data from that internship and then cross analyze it with a much larger data set. So this data set has 63 different CSV files of city trees, or city tree inventories, I'm sorry, and it provides things like tree location, species, nativity status, health, size, specific location, etc. And in terms of their location and their specific location, it uses longitude and latitude coordinations to find out, or coordinates to find out specifically where the tree is located. But I think it could benefit from a system like Cartograph where you can actually visualize all of that information, except there isn't a easier coding method. Like in this class, for example, all of those things need to be done by hand, inputting data of each tree specifically. So I think that's why that system isn't utilized. But by doing this project, I want to figure out how to possibly use Cartograph in these larger data sets and find out how coding can benefit it. So, questions and outcomes. Our questions are: where is there the most biodiversity, and what city has a largest tree population? Outcomes: learn which city, New York City or Des Moines, has more biodiversity and a larger urban tree population. So we know that New York City overall is famed by the fact that it is it is the most populous, and it's the largest urban city nationally in the United States. But it also, even though it's a concrete jungle, it has specific areas that are very focused on forestry and management and things like that. So probably you've heard of it, Central Park, a very famous location for, it is in the middle of the city, but it has a large tree density and a large scale biodiversity index. And so we are going to compare Des Moines, a local city in Iowa, and New York City to figure out who has more biodiversity and who has a larger urban tree population. And in addition, find out by a mile area who has the most density, which is really the best measurement for which city overall has the most trees per its size. In terms of benefits, this will help us learn about biodiversity in Iowa because we will be able to analyze Des Moines and then use that information in Ames and other local cities to learn about their system and how we can better improve our urban forestry. And we can also find out about this nationally by analyzing all of this data, which is a lot. And how to improve and integrate trees into urban areas, sort of, which I already spoke on. So, cleaning and preparing the data, like I said earlier, we got this data from Kaggle, which is the 5M trees data set. And I looked at a bunch of different sources through Kaggle and different sites, and I realized that this one was the most thought out, and it had the most data, which honestly is a challenge in itself because there were the 63 CSV files and then 5 million trees relatively across all of those different data sets. So, in terms of Des Moines, there were 25,000 trees present, but I knew that I wanted to use data that had the latitude longitude coordinations available and the specific date it was collected also available, because it will give us a better historical viewpoint of how has tree density looked across the ages. In terms of how we cleaned the data, first worked on conceptualizing it and understanding the differences between Des Moines and New York City, and understanding that this is a very large data set. This is a lot to work with. But after I sort of figured out that I wanted to focus on Des Moines and New York City and not every single CSV file that was on this Kaggle data set, we started removing areas with missing values. So anything that said NA, going through Excel and using pivot tables, but then also I wanted that work to be provable. So I used Colab to put in the CSV file, which I had some difficulty with because of the large size of the data set and it actually inputting correctly into Colab. But we removed those missing values and then removed any duplicates, which was very rare in this instance. Missing values was really common because the data set had some areas lacking, especially in the Des Moines portion rather than the New York City portion. But duplicates weren't as common. Still input code to get any of those out. And then we looked for extreme outliers. So anything that seemed like it was outside of the borders of the major metropolitan, anything that was just very evident that it did not align with the data we wanted to find. And then fixed inconsistency in formatting just to make sure everything was really congruent and well put together. So, fixing the lettering, making sure everything is spelled correctly, making sure capital letters, silly superlative things like that, just to make sure everything was cohesive and made sense. And then when we were all done cleaning the data, the New York City set and the Des Moines set, uh, in the Des Moines set, we lost about 9,000 of the initial points because there was a lot of data that either said non-applicable or it was blank, and that was actually information that we needed. But still, going about it with 16,000 sources still was really valuable, and I feel like we were able to understand a lot from these data sets, even though we lost a portion of our data by cleaning it. So then, in terms of data exploration and descriptive analysis, we did the count, mean, standard, min, 50%. So that, you know, that's supposed to say 75%. And then the max. We did all of that in one point to better understand the longitude and latitude coordinations of different tree populations around Des Moines. And by doing this, we found the base area for a lot of those points. And our hypothesis, we presumed that there are more trees and biodiversity overall in Des Moines than in New York City because while New York City is larger, more populous, has a higher overall area, they do not have better density because they have so many large concrete jungle-esque areas. So we assume by with the information we're finding, we'll be able to categorize that data and find that Des Moines' density is better than New York City's. Current data of past sources does align with that hypothesis. I cross checked it between a few different pages, such as the US Forest Service, National Park Service, and different sourcing like that, just to find how do things measure up currently and how can we get a better, more descriptive analysis. In terms of patterns, we have longitude and latitude coordinates, which I've talked about frequently. And when measuring that, they fall on very similar lines. And occur we can assume that this occurs because of the infrastructure that was put in place, especially in the early 1900s in cities like New York City, and how the placement of infrastructure really affect urban forestry later on, and how we would be able to place trees and analyze them and check patterns and things like that. And in terms of anomalies, a handful of data exists before the 2013 to 2020 main collection period. Most of these two data sets, they were collected between 2013 and 2020. And then there were a few odd cases where there was some that said it was from 1899. I'm not really sure if that's accurate. I actually have a friend that works in map history, and she like runs her own company. So I actually went and asked her if she thinks that these sources were viable and if people were actually categorizing that now, because there were about five different sources that said they were from the early 19th century, and she said that that could be feasible. So I did opt to leave that into the data so we could just give a nod to the outliers in those uh, scatter plots and admire the fact that that data was still being collected so early on. So, overall, my project did align with this initial hypothesis, and it did answer the questions we wanted to find, even though the actual data was hard to extrapolate because there were a lot of issues in terms of the CSV files not working and then having to input them differently and trying to use Google Sheets and make that a CSV file and insert that into Python. But there were a lot of issues in terms of how the data was put in. But overall, it was helpful in understanding how tree populations are affected in urban areas today. Thank you.